semiconductor industry, a civil engineer, a metallurgical engineer, chemistry scientist, no matter what kind of engineering discipline you come from, the technology of image processing and computer vision plays a very, very important role these days. Hi, everybody. This is Dr. Karthik here. I welcome you all with this three-session webinar series on image processing and computer vision. The main aim of this webinar series is to give you a flavor of how image processing and computer vision is being extremely used in these industries these days. Irrespective of the engineering discipline that you come from, image processing and computer vision is one of the major technologies which created a lot of impact in industrial automation. Right, so any kind of industries you take, right? So that's a main aim of this webinar series. Before getting into the details, let me introduce myself. My name is Dr. Karthik. I am basically from Hyderabad. I secured All India 135th rank in year 2008 and in ECE stream. And then later I went into IIT Kharagpur for pursuing my MTech in Visual Information Processing and Embedded Systems. After that, I went into IIT Madras for pursuing my PhD. In between Masters and PhD, I worked for 6 months as an assistant professor. And teaching being my passion, I didn't want to choose any other profession as such. So, and then later I got shortlisted to work with TCS Research and Innovation Labs, Bangalore. As a research scientist, right? So this is how my career journey was. Okay, when I introduce myself like this, and many of the students majorly they feel that this guy is from IIT Kharagpur, IIT Madras, research scientist. Don't just get carried away by the profile. I just introduce for the sake of introduction so that you'll get to know about me more. The main intention behind me introducing myself to you is to let you know that this is something achievable by everybody. Okay, I was brought up in very normal colleges, schools. I'm not into hi-fi colleges and schools, but still I was able to make it. It's only because of sheer hard work. Of course, associated smart work is also essential, right? So don't just get carried away by my profile. I'll keep the things as simple as possible today. If I'm able to inspire you to choose this profession, irrespective of you may be from metallurgical, you may be from chemical engineering, you may be from electrical engineering, no matter what kind of engineering discipline you're from, if I'm able to inspire you, or if I'm able to give you some kind of information on how this is image processing and computer vision is used in your own engineering discipline in some form, then the time that I'm spending on making this webinar possible, or the management of Abdul Kalam University, right? So everybody who is involved in making this webinar possible, it's really worth it. Okay, so without wasting much time, let me go into further details. This is the outline of the talk. Let me start with the motivation, and then I'll introduce, even though these two terms called computer vision, image processing are quite often used interchangeably, one for the other, but however there's a very thin line. I'm going to tell about what is that, okay, which will be very useful for you if you're a student and you are attempting for some interviews in deep vision deep tech kind of a companies. And then I'll talk about the basic block diagram. Given an image processing and computer vision problem, how will you go for attempting it? And then I'll talk about various applications in various engineering disciplines, right? So that's also very, very crucial, right? And Python for image processing and computer vision, that's another thing which I feel that which is very, very essential these days, since Python being the open source, it's being extensively used in the industry today. I'll talk about optical character recognition as an application. Also, I'll talk about the pathway to companies like TCS Research and Innovation. I'll give you a brief idea. It'll not be fair on my part if I just tell you what are the exciting things that are happening in image processing or computer vision domain. But if I give you a flavor, or if I give you some kind of an information how you can get into companies like TCS Research and Innovation, that will be absolutely great, right? So this is what I'll be doing, right? So I'll conclude the talk. This is a 3-session plan. Session 1, I'll cover about industrial scope, and then I'll talk about some introduction about the Python and how to use Colab, Google Colab, which is one of the very great platform for you to perform some of your image processing and computer vision experiments, and then in session 3 I'll talk about more about optical character recognition application using PyTest. Right? Okay, this is a plan. Slightly some deviations will be there here and there, but however, this is the overall plan. Right? I'm just keeping a track of my time. Coming to just let's try to understand where the image processing or computer vision coming from. Why does it takes a very, very important role? See, if you see this picture, right? So vision plays 83% of your 83% role in the human perception. What do I mean by that? Okay, if you are seeing a scene by using your human eyes, okay, then that means that uh, the way you are inferring or the way you are uh, observing the scene, okay, it all depends on the way you are perceiving the scene or the scene information, however you're perceiving. Okay, it depends on the visual sensors plays a very, very important role in understanding about the scene around you. Okay, 83% 83% goes for the vision sensors. That's your human visual system, including eyes and other areas of the brain which deals with the human visual system. Right. So other sensors like touch, taste, hearing, smell, these also play a role, but however very, very minor. Okay, that's exactly the same reason why vision in if you take the motivation why image processing and computer vision is so useful is uh, vision sensors are extremely important for you. That is the reason why vision sensors are extremely used for industrial automation than compared to the other sensors. Okay, people have found out that using vision sensors, automating the industrial processes became much efficient, right? So that is a reason why vision sensors plays a very, very important role, and the technology beyond it, the image processing and computer vision, that is where it comes into picture, right? So uh, and now similar operations are generally carried out across the images. Generally, you can make use of the existing graphic processor units, the computational resources very, very efficiently because of these images. Okay, if you have heard of convolutional neural network, one of the main motivation for moving from fully connected networks to convolution network, because you can carry out the similar set of operations across all the images, right? So that is one of the very, very advantages with respect to image processing or computer vision, right? So, and every industry these days has an image processing and computer vision engineers. No matter what kind of an industry it is, there is a need for computer vision and image processing engineers. Okay, so if you're able to learn this skill, this particular subject, actually, you are closer to work with some of the most research companies existing in the industry today, right? So domain knowledge also plays a crucial role. What do we mean by that, right? So here, if you see, suppose say image processing or computer vision is being used by a civil engineer in order to inspect the bridges, how the bridges are there, are there any cracks, are there any rusting that is happening. So if this particular technology, if a civil engineer wants to make use of it and automate this process, I'm going to show some pictures. You will understand how how complex that task of bridge inspection was earlier, and now how well it can be simplified by using image processing or computer vision or the latest technology, robotics technology, which is existing today, right? So domain knowledge. Suppose say a civil engineer is operating, and he should know, right? So which crack is dangerous and which crack is not dangerous, which cracks need attention, which defects in the bridges need attention. If you need all that information, a civil engineer is very, very important at that point, right? So now the another important thing is the cost of data acquisition is huge for certain applications. If you take underwater images or satellite images, the cost of data acquisition is very, very high because an expensive camera setup is used, and if you so the one of the and then once, if you want to take a picture by using your mobile phone, if it doesn't come well, what can happen? If it doesn't come well, what is the best thing I'll do is I'll capture another picture by using my mobile phone. Okay, it's as simple as that, right? So now, but you can't do the same thing with the satellite images, right? If the satellite images has not come well because of some clouds which are there in between the satellite camera and then the earth, okay, and the satellite is moving, continuously moving, and satellite can't take another picture, right? So whatever images that you have by using in such kind of a scenario, okay, that itself will be a valuable data for you. Okay, and as a responsible computer vision or an image processing engineer, okay, it's your responsibility, okay, in order to restore those images and help the space engineers in order to and help the space engineers for further processing tasks, whatever they need, right? So you can see right from the industrial automation and the way computational resources can be used effectively, and every industry being using this technology of image processing and computer vision for their automating some of their processes, complex processes, and the cost of data acquisition being high. This itself should bring some clarity in your mind that, okay, the kind of importance that image processing and computer vision subject has today. Okay, so that if you're able to get a grip on this subject, I think you will be pleased in one of the best companies, right? And this is a basic difference between computer vision versus image processing. Okay, if you give input as an image and the output is your image, then such kind of a task is called image processing. Okay, suppose you're capturing an image by using a mobile phone and it has not come out well. Okay, if it has not come out well, what is the best thing that you will do is you will capture another image. Okay, or if there is no feasibility for you to capture another image, okay, what you can do is you should work towards designing a system in order to remove the degradations that might have caused when you have captured the first image. Maybe there's some kind of a shake because of which the blur was introduced, or there's some kind of a low light because of some kind of a noise was introduced in your image. Okay, now as a part of an image processing system, okay, you should be able to build such kind of a system where the input is an image, the output is the improvised quality image, right? So this is maybe denoising comes under image processing, dehazing comes under image processing. I just for some of the interesting results that we had with dehazing during my PhD days, right? So this falls all the tasks which takes image as an input and image as an output comes under image processing. Okay, now if the input is an image, okay, and you want to design a system which can tell you what kinds of objects are there in your image, okay, then that means that actually you're giving some kind of a description after reading an image, right? So such kind of a system, okay, such a system which performs this task of giving input as an image and output it giving you some information of what kind of object is there on image, such kind of an example task, okay, whichever system does this kind of a task actually comes under computer vision category. Okay, the computer graphics, artificial intelligence, I'm not going to touch about it. However, I'll tell you how artificial intelligence is being used in solving some of these tasks on computer vision or image processing, right? So now this is the basic difference between computer vision and image processing. Okay, now this is a basic block diagram. I think this is one of the most important things that you should keep it in mind whenever somebody is giving you to solve the task on image processing or computer vision. Okay, this is the basic block diagram that you should keep in mind. Okay, the first thing is data capture. How you are capturing the data, whether you are mounting your camera on top of a drone, whether you are mounting your camera on top of a robot, underground robot, right? So, or you yourself are capturing the images. Okay, how well you are capturing the images also plays a very, very important role. Suppose you're mounting the camera on a drone, okay, and whatever vibrations that the drone might be having because of the fan movement or or any other kind of vibrations that the drone have if there is any possibility, such kind of a possibility, okay, then you should account for those, account for the noise introduced because of those vibrations also. Okay, and you should be able to design a system if there is no feasibility for you to account for the noise, then you should at least be able to build the drone very, very effectively so that such kind of a noise is not introduced into your images, right? So now so sometimes what happens is no matter what kind of control that you have on the platform which the camera is being carried, okay, no matter what kind of a control you have or no matter how robust it is, there's always some kind of a noise that will be introduced into the images or the videos. Okay, so because of which you need to understand how to pre-process this image before giving to further tasks. You should be able to remove the tasks. You should be able to remove the noise or the other form of degradations which are introduced into your image. That comes under pre-processing block. Okay, and after which the feature extraction. Okay, and neural networks are the popular feature extraction blocks these days. How well you are able to extract the features from your image, that itself is a feature extraction block. Okay, suppose you are designing a system which can automatically detect whether people on the streets are following the social distance mechanism or not, because now that the case of the COVID-19 is there, it's very very important that people should follow the social distancing rule, right? So now if they are not following, then they should be able to you should be able to give the signal back to the authorities saying that okay, these regions people are not adequately following the social distancing principle, so that they'll come into action. Okay, so how you will be doing that? Okay, suppose you are installing a surveillance camera. Okay, traffic surveillance cameras were very very common these days, and what you can do, what the best thing that you can do is you can use that surveillance data, the video or the data that is being captured by the surveillance cameras. Okay, and you can out of all the objects which are there in the scene, okay, the only objects that really matter to you are the people who are moving on the streets, or people who are there. Okay, so you're able to identify the people. That is what the region of interest says. Okay, and to identify that region of interest, it should be very very important that you should be able to extract some features out of your image. Right now that comes under feature extraction block. Okay, once you have identified your region of interest, and then now you should be able to check whether two people are at a sufficient distance apart, so that the social distancing rule is still maintained. Okay, that comes under scene inference. Okay, whatever you want to do after identifying the region of interest is called the scene inference. Okay, this is a basic block diagram, right, given in. So now there are several different steps for you. The data capture is happening with surveillance camera, and if there is any noise, you will deal it in the pre-processing block, after which you want to extract the features out of your image. Out of the features that are identified, which features are corresponding to the people who are moving on the streets, and then after which you have to do enough scene inference, whether to want to check whether two people are sufficiently with a sufficient distance apart, right? So that you can verify whether this social distancing rule is being followed or not. Okay, so where do you want to contribute given this problem? Where do you want to contribute? Whether you want to improve the quality of the data that is being captured by the surveillance camera, or you want to work towards the designing of surveillance camera itself that comes in the data capture, and then you want to extract the features. You want to design a neural network which can extract the features, or you have to suppose you have extracted the features, you have to identify the regions of interest, right? So whether which regions of the scene image that you capture or the video that you capture are belonging to the people, right? So now after which you have to do scene inference, whether which point you want to contribute or which point you want to bring the novelty over the existing algorithms which are there is what you need to work towards, and then only you'll have the clarity. Okay, these are the set of pre-processing tasks are there today, and then I want to work towards improving the quality of the surveillance videos, whatever surveillance camera must have captured, right? So now you can work towards contributing towards this pre-processing block alone. In the similar way, you can decide which block you want to contribute towards. Okay, and now this is how it's being. Now we'll talk about several different applications. Some of the exciting applications which are being handled in in various industries these days. This is how it's being used in the semiconductor industry. If you have seen, these are the wafers, silicon wafers, on top of which small chips will be manufactured. Okay, if there are any defects on those chips, it's very important as an image processing or a computer vision engineer. It's your role is to automatically identify these defects, and then help the engineer who is working with the in those locations, tell them, okay, this chip is defective, it should not be used for further processing. Okay, that's now how you'll be manually. If you are seeing it, it would be very difficult for people to manually go through the silicon wafers, right? So what you can do is you can install a camera, and then you have you may have some conveyor belt kind of a setup where these chips are going by, and then after which the camera, from the data that the camera captures, actually you can design your pre-processing algorithms, or you can design your image processing or the computer vision algorithms in such a way to identify these defects. Okay, this is if you have known about electron microscope images, so this is how it is being used. Suppose say these are the electron microscope images which can observe the objects at a very microscopic scale, majorly used by people in metallurgy engineering in order to understand the characterization of the materials, and people in the chemistry or people who are working in sciences, they majorly uses electron microscopic images, right? So now, so these microscopes capture the images at a nanoscale or a micro scale. Now, when a device is capturing images in such kind of a fine scale, what will happen is even the minutest of the vibrations in the devices can induce the noise in it. Okay, now it's your responsibility as an image processing or a computer vision engineer in understanding or modeling those vibrations, and understanding what kind of a noise is introduced into these images, and then work towards improving it. Okay, and if you see here the left hand images, the two images on the right hand side, okay, there are few regions actually you can there's a lot of noise that is being induced, okay, and but there are few regions where there is a noise is not at all there. Okay, these regions, it gets smoothened out, the denoised image actually. Okay, this is how it's being used in the for the railway bridge inspection. If you see the image on the left hand side, there's a huge crane, and then the people are standing on that the base of that crane, and then you instruct the people, the crane driver, and then to move that crane handle, whatever you call that, right? So to move it, and then these people will be inspecting the bridges. You see how risky it is, right? Now, nowadays, after the advent of using drones, right, people are effectively using the drones. If you see here, the drone which carries a camera, which continuously inspects the bridges. Okay, on my right hand side image, it continuously inspects the bridges, and it reports back to the engineer who's working on to the ground level, and saying that, okay, this place has some kind of an defect. Okay, or even the engineer who is working at a faraway location, at a safer place, or who is operating the drone, he'll be continuously seeing the camera feed which is being sent by the drone. And now this drone, because from which he'll be able to identify whether a particular location is perfectly fine or it needs some kind of an attention, and then people will go in order to repair it. Okay, maybe the days are going to come when the robots will automatically go to that location and then repair it. But for now, I think this is what we need to look at, right? So now the railway bridges are not only on the top of the water surface, right? So there'll be few bridges which are there under the water surface, and now this is how it's being used. Inside the people, they used to send people in order to identify which portion of the bridges inside the water is defective and which portion is not. Okay, people, and see such kind of a risky environment people will work in. This is another guy who's working close to the bridges and trying to see whether if the complete bridge structure is perfectly fine or not, right? But nowadays, people have started deploying underwater robots. These robots, if you see, will sit inside the water, go inside the water, and inspect the bridges, and understand if all the bridges are perfectly fine, they're working perfectly fine, are free of defects or not, right? And this is another interesting application. If you see, it, there'll be you must have seen, right, on the road sometimes what happens is, if there is any leakage in the drainage pipelines, or if there are any defects in the sewage pipelines, there will be a lot of water which will be gushing out, and then it will create some kind of an unhygienic environment, right? So, and now for it will be difficult for the people to understand which portion of the sewage pipeline is majorly affected, right? So now, earlier what they used to do is they used to send people and then do it, but now these days people started building these kind of robots in order to understand where the defect is, so that they can go to that particular location and understand, okay, what can be done, right? So this is how the robots or the image processing technology, because now this robot, if it has to navigate, then what should it should have some kind of a camera installed with it, so that the camera so that the robot goes inside these pipelines. Okay, this is, if you have seen the companies like Google, Tesla, all these companies are working towards building driverless cars these days, right? So now these driverless cars are equipped with a lot of sensors. Okay, and every sensor has its own limitation. And if few suppose, let's take, and since this is a topic on image processing or computer vision, let's take the vision sensors, how they will do it, right? So now if you take the vision sensors will be able to clearly see through the environment if there is no haze or fog in its surrounding environment, right? So now, if there is some kind of a haze or fog in the surrounding environment, then the vision sensors absolutely will not work properly at all. Okay. Now, if we have to make driverless cars in such kind of an risky kind of an environment, suppose a driverless cars is operating on a hill station as shown in these pictures. Okay, what you should do is your system should have enough intelligence in order to remove the haze or the noise that can happen on these hill stations because of the fog or the mist or the haze that happens. Right? So the effect of the haze or the fog which is being induced in these cameras should be able to work towards your system should have enough intelligence in order to remove such kind of an noise from the videos, right? So now, then only you can build such kind of a technology, the driverless car technology on these hill stations. This is another example which I was personally working in during when I was doing my PhD at IIT Madras, right? So now, if you see the left hand side images, the rectangular boxes on the left hand side images, both the top one and the bottom one, okay, it has the visibility is very poor, okay, whereas in the same regions on the right hand side, if you see, the visibility has been improved now. Okay, this we call it as a dehazing technology. The approach in order to improve the quality of these images is called dehazing. I'm removing the hazy kind of an effect from my images or the videos that I'm capturing. Okay, this is another container yard surveillance, right? There will be a lot of containers you must have seen in movies, right? Or if you have ever went to ports, there will be tons and tons of containers lying around in these shipyards. Okay, which container is coming in, which container is going out, it will be very, very difficult to track manually. Okay, and it's very, very important also to track such kind of an container flow, which container is coming in and which container is going out. Okay, now if you want to do that, then what manually doing it very, very difficult. What you can do is, as and when the container is coming in, you can install a camera at the entry point, and then the camera will be continuously looking at it. So, and then it should be able to identify the text on these containers and then infer what the text is. Okay, we'll look at how to identify the text. This is what is the optical character recognition technology. I'll show you a demo in the third session on how optical character recognition technology can be used in this kind of a scenario. Now, this is another example, right? So now, if you see this, the right hand, the third image in this, third image towards the right hand side, this is the aquarium that we have used in our lab in order to do few experiments. My research area was in underwater imaging, and then we were doing few experiments with it. Okay, the point which I wanted to drive through this, the third image in this, which is present in this slide, is the camera is looking downwards, or in order to do this. Okay, just because I want to do experiments on in the area of underwater imaging, I cannot directly jump into oceans and do experiments, right? You need to have a starting point that should be small at a very lab scale. That's the reason we built this aquarium. And then we started doing experiments in our swimming pool, institute swimming pool, where the waves are little natural now. Okay, I don't have a control on the waves. Here the waves I have a control. The waves which I generated in the second image, which is shown here in the middle image, which is shown here, are generated by using the hair dryer. And now suppose these kind of distortions are now uncontrolled in swimming pool, and then I can go to, later I started collaborating with this National Institute of Ocean Technology, Chennai, in order to do some of the exciting stuff they were looking for at that time, right? So now, this is what is the basic thing which I wanted to drive through this slide. Is you should always start with lab scale. You have an idea, you should implement at a lab scale. People majorly now that it's a world of entrepreneurs, entrepreneurship is on a roll now, right now, right? So now you should build a prototype. Whatever idea you have, you should build a prototype, and then they'll start looking for investors who can fund your idea and everything, right? It's very, very important for you to understand how do you develop the prototypes at the lab scale first. Digital heritage sites, digitizing these heritage sites, there'll be some broken statues which are there, which will be there. And if you want to digitize this complete location, that means I don't have a feasibility to go to the temple, but I want to have a feel that through by means of web browser itself, I want to navigate through the complete temple. If I want to do that, I have to first, when I'm trying to digitize this complete temple into a 3D model, what can happen is this broken statues will be just like that. Okay, this broken statues. This is a middle image. This is a 3D model which is extracted without any kind of an post processing. Okay, but if you see here the rightmost image, the third image in this slide, if you see the broken part is being very nicely recovered in this third image. Okay, now this third image this is third image shows the 3D point cloud. This is 3D model actually. Okay, now this 3D model itself can be used in digitizing this complete heritage sites. Okay, this we call it as a 3D in painting technology. COVID-19 detection, right? So nowadays, COVID-19 is increasing day by day, and then if you want doctors to do everything from the first inspecting your X-ray images to the point to help you to treat if a particular patient is suffering from COVID-19. If you want to doctors to do everything, then it will be becoming a very very tedious task. Okay, and doctors will not be able to manage all the things. Okay, now if you see this here, there's a technology now. X-ray images are being used in order to for the COVID-19. Now, can I use some of the latest technologies like machine learning, deep learning, in order to detect some of the regions where where you think that okay, this is a region which is being infected with COVID-19, and whether it's a COVID-19 or it's a pneumonia kind of an sign, okay, or it's normal. Okay, you should be able to design your system in order to detect this. Okay, so this is what is being done. There's some more applications. Maybe in the next session I will talk more. Okay, so this is what I wanted to cover today, and I think you should be able to get an overview, right? Starting from semiconductor industry, or a civil engineer, or a metallurgical engineer, or a chemistry scientist. So no matter what kind of engineering discipline you come from, it's very very important these days for you to understand that okay, the technology of image processing and computer vision actually plays a very very important role these days. Okay, hope you got something out of today's session, and then I'll catch up with you soon in the second session. Bye.